Good morning, dear learners and viewers at home. Today we are going to take a further look at the aspect we started with during the week titled Bearings and Distances. We've considered the first part, and today we're going to consider the 3-digit bearing, also known as the Surveyors method. It involves using the 3-digit numbers. That is, we use 3 figures to indicate the bearing of a particular place or a particular location. The angle involved is measured in degrees from the north in a clockwise direction. That is, the reference point being always the north, we go in a clockwise direction. That's how angles are measured under the Surveyors method, or the 3-digit bearing. Let's take a look at this. For instance, this indicates a question which we're going to solve. Here we have the north, directly opposite. We have the south. To my right, we have the east. And to my left, we have the west. The 3 digits here indicates that this is 0, 0, 0 degrees. And therefore, this stands for 0, 90 degrees. Then, which means from here to here is a right angle, 90 degrees. And from here down to the south, which is east to south, is also 90 degrees. Which means 90 plus 90, 180 degrees. So this is 1, 2, 3 digit degrees. 1, 2, 3 digit degrees. 0, 0, 0, 3 digit degrees. And when we count here, 45 plus 180 gives us 270 degrees, which is another 45 degrees added to this. And from here back here, we have 360 degrees in a clockwise direction, which is a single revolution. And the starting point, the reference point, is always 3 digits under the 3-digit bearing. Now we're going to use this in solving question in our examples. Let's take a look at the example. The example says, answer the following questions using the diagram showing the bearings on which each aircraft is flying. We have aircraft taking off and following different bearing into different directions, which is what we have here. These are the aircraft A301, F004, B737, E307, and we have C105. These are the various aircraft going on different bearings. Now let's take a look at the first question. Which aircraft is flying on the bearing 225 degrees? Which aircraft is flying on this degrees or on this bearing? Now taking a look at this, because we must always go clockwise under this 3-digit bearing, we have from here to here 90. Now let me put you through a little calculation. Now, this is a complete circle and is divided into various parts, but they are all even, equal degrees apart. From here to here is 90. And between this place and this point, we have 1, 2, 3, 4, which means 1, 2, 3, 4. That is 90 degrees divided by 4 to know what each one of them is. 2 goes here 2, 2 goes here 45, 2 goes here 1, 2 goes here 1, 2 goes here 2.5. And that gives us 22.5 degrees, which means from the reference point north to this point is 22.5 degrees. Plus another 22.5 gives us 45. And so on like that. So let's count all together. How many parts? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and back to 16, which means it is divided into 16 parts. If we multiply 16 by 22.5 degrees, we'll get 360 degrees. That's one of the ways to work it. But let's quickly solve this question. 225 degrees. Let's locate it here. From here to here is 90. From here to here is 180. From here to here is 270. And 270 is bigger than 225 degrees, which means the plane is in between this and this point, which is the south and the west. And which plane is here? This is the plane. And that is B 737. And that's our answer. Proving this by calculation, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which means 22.5 times 10 can be used to solve it. And that is to say, we can also say 360 degrees over 16 times 10. This can also give us the figure 225 degrees, which will prove this. We can use this, we can use this. If we use this, it gives us 22.5 times 10 degrees. Let's use this first. When we multiply a decimal number by 10, what do? We shift the decimal point to the right by the number of zeros, showing the digits. So we have 2.5 times 10, which is going to give one digit back, and that is equal to 225 degrees. And that's a proof that it is 10 parts starting from this point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's B 737. We can also go through this. How? Let's go. Let's take 4. 4 goes here, 4. 4 goes here, 9. 4 goes here, 0. Let's go further. 2 goes here, 2. 2 goes here, 45. Then 2 goes here, 1. 2 goes here, 2. 2 goes here, 2. Then 0.5. Multiply by 10, just as we did here, and that gives us 225 degrees. So that's the proof to show that answer is B 737. And that is the aircraft flying on this particular bearing, 225 degrees. So take note of that. You can use this method, you can use this method. Each one of them is quite direct, depending on the one you feel is easier for you to use. Now, this was based on angle at the point equals to 360 degrees, so we will have 360 all over the number of parts. And we locate the plane, and from there we get our answer. Now, number 2 is asking us, F004 is flying on which bearing? That is, the aircraft with this number is flying on which bearing? To find this, what do? Where is F004? Here is it. F004 is on this. So we go back to the reference points. We have 1 from here, 0, 0, 0 degrees. 1, 2, 3, 4, 5, 6, 7. So I'm bearing number 7 based on the division, and that gives us 22.5 degrees multiplied by 7, which gives us the answer, degrees. Don't forget. 7 times 5, 35. 7 times 2, 14. 14 plus 3, 17. We have 1 left. 7 times 2, 14 plus 1 is equal to 15. And don't forget the decimal point, 1 digit before the last number. So you bring down the decimal point. Degrees. Which means the F004 is flying on 157 degrees, 157.5 degrees, and that is the final answer. So the answer is 157.5 degrees. With this, we've come to the end of using the 3 digits method of bearing to solve questions, or the Surveyors method in solving questions. So you use the same way in solving similar questions. And this can also be solved using this, which is 360 degrees from here. So we now have 1, 2, 3, 4, 5, 6, 7. 7. So we have 360 degrees, which is the angle at a point as the total. And from there, we calculate that together. With this, we've come to the end of today's example. And I'll say we'll see you next week for further topics in mathematics. Stay safe, stay at home. Bye.